Is the ground beneath our feet actually shattering into pieces? In 2022, scientists recorded a gigantic rumble coming from the middle of the Atlantic Ocean, so loud it woke people up on the island of Bermuda. This sound was caused by an underwater earthquake, but its epicenter was unusually far away. It was also unusually deep. At 3,700 meters below sea level, that's as deep as 38 giraffes stacked on top of each other. And this quake was especially puzzling because it seemed to be coming from an unusually quiet part of our planet. So what could have caused this enormous underwater earthquake? And is it a sign that the ground beneath our feet is falling apart? To answer this question, we need to travel to the very center of the Earth, which is really hot and made mostly of iron. The inner core is surrounded by the outer core, which is also made of iron, but it's less dense because the pressure is lower there, meaning some of the iron has turned into liquid. Here, swirling currents are generated by the heat coming from the inner core, which then transfers its energy to Earth's mantle. There, convection currents drag heat from the core to the surface, which is why we can use the heat coming from inside the Earth to keep nice and toasty in Iceland. But these currents don't just transfer heat, they also transfer momentum, creating giant rotating currents in the mantle called Earth's geodynamo. These currents move large sections of the Earth's crust, which is why the continents drift around on Earth's surface. But these continental plates aren't the only thing moving. Within the mantle itself, materials are constantly shifting around. When the material is cooler and more rigid, it behaves like plastic, slowly deforming over time. But when the material gets hotter and weaker, it flows more like honey. Now, the mantle isn't quite as hot and runny as honey, but when you consider that honey can be as runny as string, I think you get the point. Okay, maybe that analogy was a bit weird. My point is that in some parts of the mantle, rocks behave more like a viscous liquid than a solid. And it's in this strange state of matter that the key to this mystery lies. In 2022, most of us were probably paying more attention to what was going on with the British royal family than what was happening in the middle of the Atlantic. So, when the seismic waves of this mysterious quake reached the monitoring stations on land, they went unnoticed. That's why it took researchers almost 2 years to even realize what had happened. But luckily, there were a lot of instruments in the water already, because this was the area covered by the so-called Azores Triple Junction, an area where 3 tectonic plates meet. It's here that magma comes up from the Earth's mantle and creates new oceanic crust. And since 2015, scientists have been observing something strange. This part of the ocean floor that is usually so seismically calm has suddenly become much more active. Since 2015, the number of earthquakes in this region has increased by a factor of 40. And while that sounds scary, if you live in California, you know that not all earthquakes are created equal. Most quakes are caused by the sudden slip and release of stress on one of Earth's many faults. Faults are fractures in the crust that accommodate the constant motion of Earth's plates. Some faults only move a few millimeters per year, while others move several meters in a single day. This fault in the middle of the Atlantic Ocean is one of the slowest ones. It moves only a few centimeters per year. On this map of the region, you can see how the seafloor near the Azores Islands has moved a few centimeters to the northwest in the last 10 years. You can see this movement on these satellite images as well. Between 2014 and 2020, the seamounts in this area moved slightly to the northwest. The seamounts themselves are also growing a little bigger. In fact, this whole region is gradually forming a new mountain range. This might sound like good news, but scientists noticed that this process is happening much faster than usual. New ocean floor is forming at a rate of about 10 centimeters per year, twice the normal rate. It's like driving down a highway where the speed limit is 100 kilometers per hour, but you find yourself driving on a construction site where the speed limit is only 60. In this case, the higher speed results in more crashes. To understand what's causing this speeding, we need to go back to the strange state of matter found in the mantle, which is hotter and weaker than usual. Because of this unusual high heat, The material is behaving more like a liquid, allowing large blocks of rock to sink into the mantle, much like oil tankers float on water. This process is called slab pull. As the cold, dense plate dives into the warmer mantle, it pulls the rest of the plate with it. And since the rest of the plate is attached to the seafloor, this force eventually reaches the seafloor, causing earthquakes. But why is the material in the mantle so hot right now? Well, it turns out that the culprit behind this may be the same process that keeps us alive. Our sun gives Earth's surface about 174,000 times more energy every second than we use in an entire year. And all this energy doesn't just heat up the atmosphere. A lot of it also heats up the rocky mantle beneath our feet. Scientists believe that this extra heat is causing the material in the mantle to weaken and flow faster, leading to more earthquakes. But this shouldn't really bother us, right? After all, the Earth's crust is pretty thick. I mean, the surface is only a thin slice of the whole planet. If the crust is only 5 to 70 kilometers thick, depending on where you are, while the mantle is thousands of kilometers thick, then why should we care about what's happening down there? Well, for one thing, we shouldn't think of the Earth's crust as a thin layer on top of the planet. Instead, imagine that the Earth's crust is like a sheet of paper on top of a chocolate bar. Even though the sheet of paper is thin compared to the chocolate bar, it would still rip if someone tried to tear it apart. And in some places on Earth, the thin crust sits directly on top of the liquid outer core. So if the crust weakens and breaks apart, the molten core will rise up through the cracks and create volcanic eruptions. This is why many volcanoes are located along the edges of tectonic plates. The good news is that even though the ground beneath our feet may be cracking and breaking apart, it's unlikely that we'll ever notice it. Most of the earthquakes caused by the weakening of the mantle are too weak to be felt. And those that are felt are always too far away from densely populated areas. However, in places like Japan, where the crust is already very weak, this weakening of the mantle may cause more damage. Luckily, the frequency of such quakes is still fairly low, so we won't have to worry about a doomsday scenario anytime soon. But scientists will continue to monitor this region to see whether the strange behavior continues. What's for sure is that this rumbling in the Earth's mantle is a reminder of the immense power that lies beneath our feet. The next time you take a step outside, remember that you're standing on top of a dynamic and ever-changing planet. The ground beneath your feet may seem solid and unchanging, but it's actually a thin veneer on top of a churning, rumbling mass of rock and metal. We can marvel at the power and beauty of the natural world. We often focus on the things we can see and touch. But the truth is that most of the planet's action is happening beneath the surface. So next time you're outside, take a moment to appreciate the incredible forces that are constantly shaping our world. The Earth is never far from having an earthquake, but sometimes it is simply too busy focusing on other things. So pay attention to the small details, and you might be able to catch a glimpse of the amazing forces that make our planet unique.